Bismillahirrahmanirrahim, dear students. Today's lecture number 5 for grade 12. This is grade 12. So, we start today the topic chlorides of period 3 elements. Yesterday we done this chlorides. Yes, yesterday we done these chlorides. Now, questions if you are going to solve for this topic chlorides. Yesterday, if you see the topic 13.15 topic, yesterday we completed this. So there are quizzes. Which are the following in acidic solution with water? Acidic solution: magnesium chloride, aluminum chloride, silicon tetrachloride, and sodium chloride. So acidic, when we completed the behavior of the oxides and chlorides of the S and P block elements. So silicon tetrachloride has an acidic character. Somehow aluminum chloride. Magnesium chloride is, I think you've done 6 pH, very slightly acidic. So very slightly acidic for magnesium chloride, but silicon tetrachloride and aluminum chloride will give, and slightly magnesium chloride if you go back. If you see the topics here, yes, magnesium chloride will give approximately 6 pH. So 6 is less than 7, slightly it is acidic in nature. Aluminum chloride also it is going to be slightly acidic character. Silicon tetrachloride is also acidic character. So this is the question number 1. Why the melting point of the sodium chloride is going to be very high? Melting point and boiling point of the sodium chloride is very high. We done many times in grade 9. You done also in the previous lectures. I told you same. Sodium chloride is an ionic compound. It is an ionic compound. So when you are going to arrange these ions, so crystal lattice, three-dimensionally these positive ions and negative ions, sodium ions and chloride ions are going to be arranged. So between the sodium ions and chloride ions in the crystal lattice, very strong electrostatic force is present. So when there is a strong electrostatic presence between positive and negative ions, so very difficult to break. That's why high amount of energy is required to melt or boil sodium chloride. That is why it's very high melting point and boiling point. This is question number 2. Question number 3. Why aqueous solution of reaction of phosphorus pentachloride with the hot and cold? Write down, this is at the previous section which is given here, and we done this. Magnesium chloride, sulfur trichloride and phosphorus trichloride, 2 chemical reactions are given in the 2 steps. So this is given and we done this. What products are obtained on the reaction of disulfide chloride with water? This is also on the same page on the up. If you see this topic, chemical reactions are not given, but it's a very complex chemical reaction. Is very difficult to draw, and this discussion is given and we completed last point yesterday, I think. Why aluminum trichloride is non-conductor? Aluminum trichloride is non-conductor, and if you see the topic, we done also because it does not dissociate, does not give ions in aqueous solution. The reaction, the molten aluminum chloride only possible at increased pressure, when you are going to give a suitable pressure for it, then it is going to be ionized. Otherwise, normal condition does not ionize, so it's non-conductor of electric current, does not give ions. So this is the answer for this. And sodium chloride give ions and magnesium chloride give ions and dissociate into ions, and that's why they are good conductor of electric current. So students, these are the questions, quick quizzes, you have to solve these one. Now a new topic I am going to start. New topic is hydroxides of period 3 elements. You should still we are talking about S and P block elements. Same period 3 elements. So hydroxides of period 3 elements. This is article number 13.16. 13.16. So if you are going to see first two elements, sodium form sodium hydroxide, magnesium form magnesium hydroxide. These two, sodium hydroxide and magnesium hydroxide. These are the metals, magnesium and sodium. And magnesium, sodium is more metallic in nature than magnesium, and already we done the behavior of oxides. Sodium oxide is strongly basic, so that's why sodium hydroxide is alkali, strong base. Magnesium oxide is only basic, so magnesium hydroxide is also base, but not stronger as compared to sodium hydroxide. This is called MnCaf. Magnesium, these are the ionic compounds. These are the ionic compounds, sodium hydroxide and potassium hydroxide in the same group, but magnesium hydroxide also. They react with acids to form salt and water neutralization chemical reaction. So hydrochloric acid in aqueous, hydrochloric acid in aqueous neutralization reaction. You will get sodium chloride in aqueous and water liquid. So this will be give magnesium chloride and water liquid. So this is the chemical reaction for this one. So these are the reactions for the sodium hydroxide and magnesium hydroxide. So colorless solution of sodium chloride is formed and magnesium chloride is formed. Aluminium chloride dear students, when we done the nature of oxides, I told you aluminium oxide. Aluminium oxide is an amphoteric. It is an amphoteric nature. It has acidic properties as well as basic properties. Same is written here. Aluminum hydroxide, like aluminum oxide, is an amphoteric. So this is an amphoteric. It can react with acid, also it can react with base. So aluminum hydroxide reacts with hydrochloric acid to form aluminium chloride and water. Aluminum chloride is formed and also water is going to be formed. So here aluminum hydroxide acts as basic nature, because it can react with acid to form salt and water. And second reaction is aluminum hydroxide can react with sodium hydroxide. It can react with sodium hydroxide to form sodium aluminate. This is sodium aluminate. So here aluminum hydroxide acts as acidic. So here acidic solution is going to be formed. So that is why, due to these two chemical reactions, dear students, so it can react with acid, it can react with base. So that's why dual character, acidic character and basic character. Then we start silicon, phosphorus and sulfur hydroxide. To understand this, I can omit. Now, remaining elements are, after this, sodium, magnesium, aluminum, then silicon, phosphorus, sulfur, chlorine, argon. So from sodium to magnesium, both are metallic and metal character decreases from left to right. Aluminum oxide gives the amphoteric, then the non-metallic character starts and they give acidic. So that is why their bonding is covalent. They form covalent bond. Written in your book, hydroxides of silicon, phosphorus, sulfur, they have a covalent nature, covalent bonded. So these compounds are acidic in nature. They are going to be formed acidic, from weak acid to strong acid towards the chlorine. So that is why their structures are covalent and the structures are given here. There are other acids also containing hydroxyl ions. So one is called orthosilicic acid. Orthosilicic acid, like this one. So if you draw a structure, silicon, but we can write like this. Like this one. H4SiO4. H4SiO4. Orthosilicic acid, just like sulfuric acid. H2SO4. Phosphoric acid. H3PO4. Perchloric acid. HClO4. So that's why orthosilicic acid H4Si4, because 4 hydroxyl ions are surrounding it. So 4 hydrogen and 4 oxygen. That's why the formula is H4SiO4. So this is a weak, very, very weak acid, orthosilicic acid. Then there is a phosphoric acid, orthophosphoric acid. Orthophosphoric acid. Orthophosphoric acid H3 PO4, orthophosphoric acid. H3PO4. So in the H3PO4 orthophosphoric acid, so there are 3 hydrogen atoms, not 4. There are 3 hydrogen atoms, so due to this reason, phosphorus surrounded with the 3 hydrogen. So due to this reason, there is the one oxygen here like this one. Like this. Like this one, phosphorus, oxygen double covalent bond, oxygen and hydrogen single covalent bond. So H3, 1, 2, 3, P, center, oxygen, 4, 1, 2, 3, 4. So this is a structure of orthophosphoric acid, weak acid, or we call phosphorus 5 acid because the oxidation number of phosphorus is 5 due to this reason. Then sulfuric acid. Sulfuric acid contains only 2 hydrogens, so that's why sulfur is bonded with 2 hydroxyl ions and 2 oxygen atoms with double covalent bond. So double covalent bond is between the oxygen and oxygen, so that's why the valency of sulfur. So 5 valency, 4 valency, 6 valency. There are 4, 1, 2, 3, 4. And here 2, 3, 4, 5. And 2, 2, 4, 5, 6. 6 group, 4 group, 5 group. So 2 oxygen atoms are surrounding and 2 hydroxyl. The formula is H2SO4. So this is the sulfuric acid. So these are the acids also containing hydroxyl groups elements, but these are one which are going to be highest oxidation states 4, 5, 6 and 7. Aluminum hydroxide is amphoteric, sodium and magnesium hydroxide is bases also basic nature. Orthosilicic acid is a very weak acid. Orthophosphoric acid is a weak acid but stronger than the silicic acid, and sulfuric acid is a very strong acid, and perchloric acid is also very strong acid. If you want to draw a structure of HClO4, so like this chlorine, maybe like this one, maybe like this, 7, 2, 4, 6, 7, HClO4, 1 hydrogen, so OH is here and 3 oxygen atoms are here. So maybe like this, this is the strongest acid. Perchloric acid is stronger than even sulfuric acid and hydrochloric acid. So this is a perchloric acid, sulfuric acid, orthosilicic acid, orthophosphoric acid. So these are the structures for these. So there are quick quizzes, must solve them. Exercise questions and quick quizzes. Justify sodium hydroxide and magnesium hydroxide, basic nature, they have hydroxyl ions. Magnesium hydroxide and sodium hydroxide, they have hydroxyl ions, they can react with acid to form salt and water. They dissociate into ions in hydroxyl ion in water, and they can react with the acids to form salt and water. That's why they are basic in nature. But if you have a litmus paper, if you have a pH paper, you can also identify them. Justify aluminum hydroxide is an unfolded oxide. In the previous rub this, the equations are given because aluminum hydroxide can react with acid, it can react with base, so it shows the unfolded nature. This is a quick quiz. Now, dear students, now we start new topic. I think it is clear for you. Now we completed the period 3 elements, dear students. Period 3 elements we finished. Now we start group 1 elements. Group 1 elements, and these group 1 elements are called alkali metals. These are called alkali metals. So these alkali metals start from lithium, sodium, potassium, rubidium, we call cesium or cassium, and francesium. Because francesium is francium we get francesium also. So this is radioactive, which is not going to be mentioned in your book because it is radioactive metals. It is present, but it is radioactive. Already I told you, that's why not mentioned here. So in the group top to bottom, lithium, sodium, potassium, rubidium, and cesium. Now we will discuss here atomic and physical properties of group number 1 elements. So atomic and physical we discuss atomic and physical properties of these elements. So number 1 is atomic radius. So as I discussed in the very first lecture, for the period number 3 elements, that atomic radius and atomic size increases from top to bottom. If you go from top to bottom, atomic size is going to be increased. Atomic radius is going to be increased. Why it is going to be increased? Addition of new shells. As we go down the group, new shells are added. So a graph is given in your book. So if you move from lithium to cesium, so atomic radius, atomic size is going to be increased because of the addition of new shell. We call shielding effect. Shielding effect is repulsive forces present between nucleus to outermost shells. So more shells are there inside the atom, so it shield for the attraction. So due to this reason, shielding effect also increases because new shells are going to be added. So atomic size is also going to be increased. Atomic radius is going to be increased. So see the table which is given. Atomic radius, atomic volume for lithium is 12.97, sodium 23, potassium 45, rubidium 55, and cesium is a 69. So going to be increased as we go down the group. Now second one is this atomic size increases. Ionization energy, or we call ionization potential. Ionization energy or ionization potential. These you done in the lower classes. ionization energy and ionization potential, the minimum amount of energy is required. The minimum amount of energy is required to remove the electron from the valence shell of an atom which is loosely bonded to form in gaseous state to form a positive charge. Electron is removed to form positive charge. So minimum amount of energy is required to remove the electron from the loosely bonded atom outermost shell in gaseous state to form a positive ion is called ionization energy. Just like we are talking about here, first ionization energy. First means only one electron. Remove only one electron. The amount of energy is required to remove one electron from the atom loosely bonded in a gas state to give a positive charge. Energy is required, we need. So, dear students, we know that group number 1 elements from lithium to cesium, they have general electronic configuration NS1. NS1. N is a principal quantum number. Lithium is a 1s2. This 1s2, 2s1, 3s1, 4s1, 5s1, 6s1. So this is a principal quantum number. Number of shells. So this is the general electron configuration NS1, one electron is present. So as I told you that ionization energy decreases as we go down the group because number of shells are going to be added. So number of shells is going to be increased. 2 shells, 3 shells, 4 shells, 5 shells, 6 shells. So that is why if I remove the electron from lithium to cesium, so we need less amount of energy. Decreases as we go down the group, this amount of energy decreases. So this is called a ionization energy. So this is a metal, should be in a gaseous state. So the amount of energy is a zero charge. So it gives a positive 1. Metal positive 1 charge, 1 electron is going to be removed in a gaseous state, and this is the 1 electron is going to be removed, and we need amount of energy. So this is the ionization energy. So ionization energy, if you see the graph, slowly and gradually it is going to be decreases from top to bottom. Alkali metals, they have very low ionization energy as compared to the other group of the elements in the periodic table because they have only 1 electron in the valence shell. So due to presence 1 electron, so that is why it can be removed very easily. So they have the least ionization energy. They have a very more metallic character. Weak bond is there. Easily electron can be removed. So lithium to cesium, so you can see the first ionization energy of group of one element, it is going to be decreases. So this is number 1. Then electronegativity. Then there is electronegativity. Electronegativity is the ability of an atom to attract shared pair electron itself. The ability of an atom to attract shared pair electron itself is called electronegativity. So you know alkali metals, they have only one electron in the valence shell, and as we go down the group, number of shells are going to be increased. The distance from the nucleus to outermost shell is very high, so they are not going to be attract electron. They are electropositive. They are not electronegative. But if we compare from lithium to cesium, so this lithium has very small size. Only 2 shells are there, and cesium has the largest size. If you compare, then we can say from these elements, lithium is a more electronegative and cesium is the least electronegative. So electronegative character decreases as we go down the group. So as you see the table here, electronegativity for these elements, lithium, sodium, potassium, rubidium and cesium, so electronegativity is going to be decreased. If you see the graph, dear students, electronegativity of potassium and rubidium. Potassium and rubidium you will find approximately similar, same. This is due to the structure of the sodium and rubidium. Structural size, structure, nature of the structure. So due to the nature of the structure, the electronegativity of potassium and rubidium, there is equal, approximately equal. So this is energy of atom is going to be absorbed when we are going to remove the electron. So amount of energy, so this electronegativity means the ability of an atom to attract shear electrons. So in the very first lecture I told you, fluorine is the most electronegative according to Pauling scale 4 electronegativity. And cesium and francium because it is radioactive element, again I am telling you. So cesium because there are compounds of cesium, that's why. So cesium is the most electropositive, least electronegative. Fluorine is the most electronegative element according to Pauling scale. So there is another thing also. These elements, alkali metals, they impart characteristic flame on the Bunsen burner. So just I am giving you example. If you at your home there is common salt, sodium chloride, and if you put on the fire, it gives a golden color. Golden yellow color it will give. Or you can see street lights, hospitals, airports, street lights, these are called sodium vapor lamps. So golden yellow color is formed. So potassium give a violet color, sodium give a yellow color, and different elements give different colors on the flame. So this is called a flame test. We call flame test. The properties of alkali metals to give a coloration on the Bunsen flame. So this is used for detection of the elements. Just like because of all these are colorless salts, white salts, crystalline salts. So if we have a sodium chloride and if we have potassium chloride, so how I can identify, because both have the same color, so I put on the Bunsen flame. So sodium chloride will give a golden yellow color and potassium will give a violet color. So that's why you can identify them. So this is for the identification for this one. So we are going to finish up to here. Inshallah, next time we have another topic, melting point and boiling point. This is different. That's why go through these topics and you have to see very well, and also solve exercise questions. So please bring your books. You should have books and pen, pencil, because we have to solve the questions. So thank you very much for this.